Welcome to this video. Today we'll be talking about how to take the derivative of trig functions and also a little bit about the chain rule. The chain rule applies largely to taking the derivative of trigonometry functions and a few others. But let's jump right into an example here. Let's say I have the cosine of 3x to the fourth and I really wanted to take the derivative of that. Well, it can be kind of confusing because I have a function of cosine and I've got a function of x within the cosine, so how do I approach this? Where do I start? Well, my first step is to only worry about the cosine, and I'm going to ignore whatever's in the cosine. I say, what is the derivative of cosine? I'm just adding this clip in really quickly for those who may not understand trig derivatives very well. If you want to skip, you can skip here to the rest of the video. If I have the sine of x, and I want to take the derivative of that, well, that would go to cosine of x. And if I have the cosine of x and I wanted to take the derivative of that, I would have negative sine of x. And if I have the negative sine of x and I wanted to take the derivative of that, well, the sine of x derivative is cosine of x, so it's clearly going to be negative cosine of x. And if I have the negative cosine x and I wanted to take the derivative of that, well, since the cosine of x is the negative sine of x, then negative cosine is obviously positive sine of x. So we're seeing a pattern here. So these are the derivatives of sines and cosines. That's all you need to know to take the derivative of sines and cosines. Going for tangent, you'd think it would be cotangent, but surprisingly it's actually secant squared of x. These are some basic trig derivatives that should get you through most of the basic problems. Hope this is helpful. Here's the rest of the video. Negative sine is the derivative of cosine. So I'm just going to write the derivative of cosine with the same internals. Now I've focused on this part, so now I'm going to focus on just what's inside the sine. In this case I have 3x to the fourth, and I'm going to take the derivative of whatever is just on the inside. And I'm going to multiply it with what I already have. So open a multiplication bracket. The derivative of 3x to the fourth is 12x cubed. And that is literally the derivative. It is that simple. What did I just do? I'm going to go over it one more time. I've lost my eraser temporarily, so I'm using a sock. Figure that's, the cool thing to do. Cosine, I just look at my trig function and take its derivative. If it was 5 cosine, then I would have negative 5 sine as the derivative, because then 5 is a constant multiple. So literally all I have to do is take the derivative of my trig function and keep the same internals. Just like that. Just keep whatever's inside, bring it down. And then I'm going to take the derivative of whatever is in between those parentheses and multiply it by what's already there. In this case, 12x cubed. And that's the process to take the derivative of trig functions. Not too bad. Why don't we try another example, maybe one a little bit more challenging. I'll write down sine of x squared plus 3. Well, how do I approach this? The first thing I want to do is say, what's the derivative of sine? And that's all I'm worried about. Cosine. And then I'm going to write the same thing that the sine had, x squared plus 3. Now that I've done this, I'm going to only care about what's in between those parentheses. And I'm going to say, well, the derivative of this is going to be times 2x. And we can simplify that to 2x cosine of x squared plus 3. And we have our derivative. Moving on to another one. How about cosine cubed of 2x? This one's different because cosine has a power to it. And this one can be kind of confusing if you've never done it before, but it's not too bad. And it's a lot like the chain rule on any other function. All I'm going to do is bring the 3 out front. 3 cosine squared of 2x. It's just like taking the derivative of x squared, only this time it's, or x cubed even, this time it's cosine cubed, so 3 cosine squared of 2x. Since I've handled this power, now all I'm going to care about is this cosine, and I'm going to say, what's the derivative of this cosine? Times negative sine of 2x. And then I've covered the trig function, so now I'm going to cover the function on the inside of the parentheses. The derivative of 2x is just 2. So we can simplify this to say, I'm going to pull this negative out front as well and say negative times 3 times 2 is negative 6. Cosine squared of 2x times sine of 2x. And that is your derivative of that trig function. It is simply, the chain rule is simply one function at a time. The outermost function is the cube, so we just worry about the cube only. Once we've done the cube, then we worry about the trig function. Once we've done the trig function, we worry about what's inside the parentheses. And we can easily find derivatives in that matter. I hope this video was helpful. If you have any more questions, you can take a picture of it and post it on facebook.com/jokoengineering, and I'll be happy to make a video response if I can. Please subscribe. That is the best way to help me, and I will talk to you later. Have a great day.